Welcome to the next video in this unit called Solving Rational Equations. We have been using some simplification techniques to simplify different rational functions that have multiplication, division, addition, subtraction. These are actual equations, so they're going to be equal to something. We're going to actually solve for the variable. So you can see here that we have three rational functions in an equation. So we have 1 over 6k squared is equal to 1 over 3k squared plus 1 over k. So the first method that we're going to employ here is we're going to multiply both sides by a common denominator and then simplify all the fractions. So the first thing to do here is to find a common denominator. And these are three different denominators. They're made up of different pieces, but they are different, three different denominators. So it looks to me like the common denominator, if I were just going to have a little area over here, I would notice that the biggest value or exponent of k that it has is k squared. And then if I look, the least common multiple between 1, 3, and 6 is going to be 6. This is my common denominator. So what I want to do is I want to multiply both sides of this equation by 6k squared and then reduce everything. So I'm going to multiply 6k squared all the way across, all right, and I'm just going to write it out. So I have 1 times 6k squared is 6k squared over 6k squared, which you can probably see is going to be 1. Then I have 6k squared over 3k squared for this one, and then minus 6k squared over k. All right, so I'm going to reduce each fraction. Well, you can see here that 6k squared over 6k squared is just 1. So this is 1 equals. On this one, the k squareds cancel. The 3 goes into the 6 2 times. And here I have the k squared and the k cancel, leaving a k here, 6k. And so now I have just 1s in the denominator, so that worked. It worked out well. If I end up with a k in the denominator, then I did something wrong. And so now I'm going to just solve. So I'm going to subtract 2 to the other side. That's negative 1 equals negative 6k. And so k is going to equal 1 over 6. All right? And so that's how you do that problem. Okay, so here's another type of problem, the same type of problem. I still have three rational functions, three fractions, but I have an equation. So I'm looking for a common denominator. So I'm going to do a little bit of analysis before I get started on here, and I'm going to look at v squared minus 5v, the denominator that's already in two of my fractions. I'm going to factor out a v from both of them, both of those terms, and I get v times v minus 5. All right, and I did that because I notice here this and this are the same, but this is just a v. But once I've factored this out, this also has a v. So it's very, very close to having the same common denominator. Very close. So it looks to me like my common denominator is going to be v squared minus 5v. All right, so when I multiply both sides by that, v squared minus 5v, v squared minus 5v. Then what I'm really multiplying it by is v times v minus 5. Okay? So as I multiply this one, I have v squared minus 5v over v plus, and then if you'll notice, this and this will cancel. So I'm just going to go ahead and do that, plus 12. Equals, and the same deal happens here, and so I have 7v minus 56. Now I need to reduce this, so I have v times v minus 5 over v. So can you see that the v's will cancel? And so I have v minus 5 plus 3v plus 12 equals 7v minus 56. And all I really have left to do here is to collect like terms and solve for v. So I have 4v, I'm going to subtract to the other side, since there was already a 7 over there. And then I have, over here, I have 7 plus 56 equals 3v, and that's going to be, I want to say, I don't even know what that is, 63, yeah, equals 3v. And so then divide through by 3, divide through by 3, and you get 21. And that's your final answer. So this is a slightly different way than I did it the first time. Coming up with the common denominator that you want to multiply all the way through can be a trick, but you just have to try something. And then if it doesn't work, then you try something else. Now, sometimes you will have a proportion set up. You will have two fractions equal to each other. So you'll notice here that r plus 5, r minus 2 are two separate numbers. They both have r's in them, but r plus 5 and r minus 2, if you put a number in there, those would be completely different numbers. So I have four completely different numbers. But what I could do is I could multiply both sides by r minus 2. Over here it would cancel, right? And then this would be multiplied times r minus 2. And then over here on this side, if I multiplied both sides by r minus 3, this would cancel, and I'd have r minus 3. Well, what that is that's cross multiplying. And you'll notice that there's an equal sign across here. But it doesn't violate the rules of algebra. It's just that it's not a trick. There's actually a reason behind it. So on this one, you would have r minus 2 times r plus 7 equals r minus 3 times r plus 5. And then when you multiply that out, you would have r squared plus 7r minus 2r minus 14 equals r squared plus 5r minus 3r minus 15. You'll notice here that if you subtract r squared from both sides, the r squareds go away, and I'm left with 5r minus 14 on this side and 2r minus 15 on this side. Subtract, and I have 3r, then add the 14, equals negative 1. So r is negative 1/3, and that's your answer. Now, this other one over here, this is really important to note, that I cannot cross multiply this problem the way it's written because of this plus right here, right? I have fraction equal fraction, plus a number. Here I have fraction equals fraction. That's the definition of a proportion, okay? This is not a proportion as it's written. But on this side, do you see that if I figured out what this was in terms of 5r, I could make it a proportion? So for instance, I would have, this side would be the same, 5r, but this other side would be 1 plus 5r over 5r. Now think about what that looks like. What that looks like is that I have 1 over 5r, that's this, and then I have 5r over 5r, which is 1. But now I have fractions that are fraction, this is a fraction equal to 1 complete fraction. So I can actually do cross multiplying now. Now, on this particular one though, cross multiplying may not be the best option. So here's an alternative. If I can figure out how to erase this. Dink, dink. Oh, there we go. And it's not going to let me erase it. All right, so over here, instead, if we start back with this, I'm going to go do it in red, we could see that the common denominator is 5r. So let's multiply both sides by 5r. Okay? Over here, do you see that the 5r's cancel? And I have r minus 4 equals. Over here, I have 5r over 5r plus 5r. Right? Well, isn't this just 1? Right? It's plus 5r. So I have r minus 4 equals 1 plus 5r. Add the r. No, sorry, subtract the r. So that's 4r. Subtract the 1, negative 5. r equals negative 5 over 4. Okay, so if I did the same thing over here, I would have 5r times r minus 4, and then I'd have 5r equals 1 minus 5r. Well, the 5r's will cancel, and I'll end up with the same thing. So either way you do it, you're going to end up with this answer. So this requires, a little bit of algebra, so you'll have to bring your algebra out of mothballs. So on this problem right here, this is a lot like the very first problem we did. I want you to try it in your composition notebook. I want you to find a common denominator. I want you to multiply all the way through by that common denominator, and then actually solve for B. Get an answer for B. And we will be checking this one in class. Remind me that we're going to check this one in class because I want to make sure you understand it. All right? So see you then.